So now that we've been able to talk about what a GCF is, let's really practice, because this is absolutely vital and crucial to being able to do everything else that it comes to factoring. So when we look at 2x minus 8, we're going to start really basic here. 2x minus 8. We want to look at both terms, 2x and negative 8, and we want to ask ourselves, what do they have in common? So this won't always be quite this easy, but what I want you to do is I want you to think of 2x. That's pretty much in its most basic form, 2 and x. 2 can't go any further, and x can't go any further either. But the negative 8 could actually be thought of as negative 2 times 4, negative 2 times 4. And by doing that, by breaking it down to its individual pieces, or like I use the Lego analogy, the individual Legos, you can now see that they have a 2 in common. And that's the only thing they both have in common. They don't have any x's in common, and they don't have anything more than 2 in common. We can't go bigger than 2. The second one has a 4, but the first one doesn't. So really our GCF, if we label that off to the side here, our GCF in this case is just that value of 2. So if you remember, going back to our steps here, once we know what the GCF is, we write the GCF in front of a set of parentheses. So the 2 goes in front of a set of parentheses. On the factored form line, put a 2 in front of the parentheses. Well, what do we do? How do we figure out what goes in the parentheses? Well, what we do is we divide by that GCF, right? So if we divide each term by 2, it's really easy. In this case, the 2's gone, 2's gone. Look what we're left with. We're left with x, and we're left with negative 4, right? X minus 4. But that was when I kind of broke it into its pieces. Let's do a second example and see if this looks the same. So again, 10 and 22. What's the only number? So what's the only number that those two have in common? Well, again, I think the only number they have in common is 2, right? Because a 10 is really 2 times 5, and 22 is really 2 times 11. And 5 and 11 don't have anything in common. So that 2 is the only thing they have in common. But they also have an x. And here's where you got to think about this. This is x squared means x times x. This is just obviously x. So they have a single x in common. They have a single x in common. It's really important that you understand that this x is the one they have in common. Yes, there's another one here. I get that, this guy. But he doesn't have that in common with the other term. So the only thing they have in common is x. They have a single x. I know I circled it twice, but it's one x that they have in common, right? Like if you have a sibling and your mom is the same as their mom, right? So it's not like you have two moms. It's just that your mom and their mom is the same mom, right? So my GCF is 2x. We write that GCF out front in front of the parentheses. Now, I got to erase this here so we can kind of do the division. But the division we do underneath, right? We do the division underneath our polynomial. So we come back and we divide each term by the GCF. In this case, it's 2x. So when we divide by 2x, 10 divided by 2 gives me 5. X squared divided by x gives me x. Negative 22 divided by 2 gives me negative 11. And the x's cancel each other out. That's our final answer. Right there, 2x times 5x minus 11. The entire thing is the answer. That's really important that you understand that it's not just that green part or the red part, it's the entire thing together. So I really just want us to practice identifying the GCFs and dividing them out. It's one of the most important things that you'll learn because it really is crucial to the next couple lessons in what we'll be doing later. Okay, so press pause on the video and then jump in after you've pressed pause to check your answer to make sure you've gotten them correct. All right, so I've left off the very end here, but on that third question, question C, your GCF should have been x squared and y. They didn't have any numbers in common, but x squared and y. So you divide that out. You're left with the x squared y in the front, and then you're left with xy cubed and then just 16 because the x squared y cancel each other out. Here for letter question D, we have 4xy as my GCF. So looking at 24, 16, and 4, 4 was my GCF for the numbers. Then we look at x cubed xx, so x was the smallest. That's a good little trick there, is that you always look at the term with the smallest exponent. So even though this was x cubed, we can't take out 3 of them because this only has 1 and so did this one. Same goes for the y. This y, only one y to the first, so that's why it's 4xy, right? Now notice, when we divide by 4xy, we get 6x squared. I'm right down here now. We get 6x squared y cubed, and then negative 4y to the third because these x's cancel each other out. And then this last term, I left it off. I wanted to make sure it was on video for this because when you do negative 4xy divided by 4xy, people say, oh, it cancels, and they think they're done. They're not, right? Yes, it cancels, but what's negative 4xy divided by 4xy? It's negative 1, right? It's when we say something cancels using division, it doesn't disappear. It cancels as in it simplifies down to 1, okay? So hopefully that's starting to make sense. There's more practice there for you. We really want to make sure that we feel good when it comes to identifying the GCF and then dividing that GCF out. That's our goal for today. Keep working hard.